Okay, we are live on YouTube and the recording is in progress. So let's get started. Welcome to the Silicon Valley chapter of IEEE Computer Society. I am the chapter chair, Vishnu Pendyala. So today we are very fortunate to have Lakshmanan Sethu from Google, Chinmay Nerurkar from Microsoft, and Ruchi Agarwal from Netflix to discuss navigating privacy and hallucination concerns around generative AI. So thanks for joining us, Lakshmanan, Chinmay, and Ruchi. Can you please introduce yourselves and tell us about your journey into generative AI?
Sure, Vishnu. So, hi everybody. This is Lakshmanan. I'm working for Google Cloud. I've been helping enterprise customers to innovate with Google Cloud, especially on AI ML solution. Right now, focusing more on generative AI. So, yeah, nice meeting you, everyone. Looking forward to the exciting and insightful discussion with my fellow panelists.
Ruchi, you want to go?
Yeah, sure. Thanks, Chinmay. Hi, everyone. My name is Ruchi. I'm a senior software engineer at Netflix. I have been with Netflix for about 5 years now, and I work on internal operations to streamline corporate operations at Netflix, which means I help other employees to improve their productivity within the organization. And we have very recently been started using generative AI, especially in use cases where it involves customer interaction with our internal teams. So let's say chatbots or internal federated search within Netflix. So you can think about Google at the scale of just the Netflix's internal teams. So we've been using generative AI in those places, and I'm looking forward to this discussion.
Hey folks, I'm Chinmay Nerurkar. I'm a principal engineer at Microsoft Advertising. I have a background in using analytics, data science, machine learning, AI in fintech, and then for the last 8 years in ad tech. Most recently, I've been focused on building privacy compliant online advertising products using machine learning AI, mainly like deep learning, graph-based models, and of course, recently generative AI, LLMs to improve reach of advertisers, connecting them to their potential audiences in a privacy safe way.
So thank you all. So you have quite an interesting backgrounds. So let's get started with the topic. So the first question I have for you is on hallucinations. So we all know that generative AI, large language models are prone to what are known as hallucinations. So I was wondering if you can share some interesting examples of hallucinations and their risks. So who wants to go first?
Yeah, I'll go first, Vishnu. So, yeah, so generative AI is taking the world by storm. In recent close to 1 year or so, and and there are a lot of cool use cases which is possible with generative AI, and which was not possible earlier. But of course, it comes with some challenges such as hallucinations. So before we get into that, maybe hallucination is nothing but your LLMs or your large language models, which provides undesired output for which is not expected output. It generates contents on its own, right? So that is called hallucination. So I would say, in terms of examples, of course, every customer that we face, every model that we tune or on base of LLMs have been facing the hallucination problems. But yeah, there are ways to avoid it. But yeah, we can talk about that later. But yeah, there are like multiple ways to avoid it, like with better prompt engineering, or with better grounding, and or with better connecting to enterprise data. So these are the ways we can avoid hallucination. I don't want to go dive deep, but maybe we can go dive deep when that needs. Yeah.
So Ruchi is
Yeah.
raising her hand, so let her go next.
I think Vishnu, you asked for specific examples. I can give broad examples. So, hallucinations can be observed in various scenarios. So, for example, us as users, if we are going through certain medical situations, we tend to use these platforms which are very easily available to us. For example, ChatGPT these days, we would go to ChatGPT, just enter our symptoms, and it would be like, why am I facing this? This could be a very dangerous scenario where the system, if is hallucinating in that scenario, could lead to misdiagnosis, or it could also tell you like, no, it's just a simple stomach ache, you can go back to sleep, but it might be a major thing that you're going through in that situation. It could also be seen in different situations like legal, where misadvice is given from the LLM if it's not trained on that specific contextual scenario. And some other examples I could share from my experience within Netflix is, within recommendation systems, wherein, let's say if I watch few movies and I am very interested in watching a specific kind of movie, let's say comedy movies, and the recommendation system, if it's hallucinating, may result in giving wrong recommendation in that case. And if it perpetuates and it keeps on doing that, it might frustrate the user in that case, and it might also lead to consequences where the business may be impacted because of many users experiencing this kind of an inconsistency. Another could be customer support. This could be within any kind of business. So let's say if you have automated customer supports where similar queries are taken care of by a chatbot. In those scenarios, maybe chatbot, if it hallucinates, it might just suggest wrong solution, or solution that is not specific to the problem that the user is facing. So these are certain examples that come to my mind when I think about hallucination in real world.
So
Yeah,
it is interesting that yeah, go ahead.
when you're in when you're working on like a broad business spectrum, something that's handled, let's say in online advertising, right, where we cater to all kinds of car clients, and these LLMs, these Gen AI models, what they are doing is they are generating new content based on like what prompt or what information, like what you've given them as an input, right? They're trying to predict the next words, or like predict what you're trying to describe to draw out that image or things like that. And of course, hallucinations happen for various reasons, which we can get into later, but they generally manifest when the model is not able to relate to the context of a particular situation, right? And this is something like, and while experimenting, I've seen this. So let's say I asked an LLM, which is like, pretty smart, some of those on the market that have like given like fantastic marks in those quote unquote exams where they rate all these LLMs based on like which one is the best one out there and things like that, right? But if you take some of the top three and like, we played around with some of them. I don't want to like, call them out by name or something, but I had a web page about say an air crash article, right? And I said like, what would be an appropriate advertisement to show over here? And some of the replies came back saying, okay, let's show ads for flight tickets to destinations on a crash site. And that's a major brand safety no-no. And that's, without understanding the context, like now it can parse through the content of what's happening. There's an air crash investigation, air crash incident, right? But even by providing that context, sometimes your LLM, if it's not trained on how to interpret it, it'll hallucinate and say like, oh yeah, let's talk about selling air tickets right where someone's talking about an airplane crashing, right? So that's something that I've seen. Like, again, this is my experiment while working with some data, but yeah, those things manifest as hallucinations with AI models.
So Ruchi, you mentioned recommender systems, which is interesting. So do you think a lot of users are using LLMs for recommender systems, like for movies?
Yeah, I mean, LLMs are used for, I mean, one of the very popular use cases within entertainment platforms like YouTube or Netflix or other platforms like these is using LLMs within recommendation systems. And this feature is something that I would say I cannot live without, because I would go to my Netflix, and if I'm looking to watch something and I don't have something in mind, I would definitely go with the recommendation that is provided by the system itself. So if there is any hindrance within the recommendation system itself, it will cause a big chaos within the platform, and will certainly impact the business directly.
So these LLMs are front-ending the recommended systems, or they are being used as recommended systems?
They are
So
being used.
go ahead. Go ahead. Yeah, go ahead. Go ahead.
No, they are front-ended as recommendation systems, but definitely they are being trained on the user's watch history and what the pattern user follows, and based on that, the recommendation is generated.
So to give another perspective, Vishnu, so LLMs are like behind the scene, right? So it's a model which is trained on huge amount of training data, right? It can be from internet data or any other data, right? I mean, so that is something you use it on top of it. You use it for your specific use cases, right? So it doesn't classify as front end or back end. It's something, yeah, if you want to specify it's front end or back end, it is called backend because it's powered. It's LLM is a kind of model, right? In any ML world, it's a model. It's a large language model. Yeah. So yeah, recommendation systems. Yes, as Ruchi mentioned, it's pretty interesting use case which got reinvented with the help of LLMs. So those days, I mean, I have implemented a recommended system for other customers before generative AI era. So that is something with this like with the predictive engineering and predictive modeling, right? So that is something. But with generative AI in place now, the recommendation systems predictions, or I would say the performance has improved a lot with the help of LLMs. Again, I mean, recommended system is one of the major use case of LLMs. So I mean, yeah, over to other panelists. Yeah.
What I mean to say is, so LLMs are replacing the traditional matrix factorization, collaborative filtering, and all that stuff. Or are they just being used as chatbots front-ending the recommended systems?
I would say both actually. Yeah, sorry, do you want to go?
Hey, go ahead.
Okay. No, I would say I've seen both happening. So like in some cases, like yes, prompt engineering is being used to and like multi-shot learning to basically feel like what a user has done before, and then try to drive that to come up with recommendations on what the user might want to do next. On the other end of the spectrum, I've also seen like LLMs actually being used to build embeddings, which is like, again, that's another word. Embedding vectors, like vector databases, have become like a very popular thing in the era of Gen AI LLMs. So LLMs are also used to basically generate these embeddings of what a user's liking might be, what a user's intent might be, and these embeddings are then used to train other kinds of models, to drive other kind of models, optimizing for, say, what genre of, like, I shouldn't guess for a movie platform, but like, maybe what genre of movie a particular user might like, and then what they might like to watch next, for example. So using like a conventional model, a matrix-based model, some sort of deep learning based model, two-tower model, recommender systems, where you have like product to user or user to movie or user to ads in our world kind of recommendations. But the embeddings that drive these two-tower models, for example, have been built at times with LLMs.
Yeah. So yeah, in addition to that, that's a great point, Chinmay. So in addition to that, to your question, right? I mean, it can be used. So LLM can be used for chatbot also, Vishnu, and it can be used for recommendation system also. So when we talk about recommended system, of course, without embedding, there is no generative AI. So embedding is the concept where you store the similar content, in a database, right? Which is called vector database. So every cloud provider has its own, and we have a third party also. So that's how this semantic search happens, right? What I mean semantic search is like recommended system. For example, you store similar words in a database, right? It's like converted into embeddings. It's not easy. It's converting into embeddings, and then it stores in the databases, which is called vector database. And then when customer comes up, or for example, a movie watcher comes up here in this example and say like, hey, he watched it, and they looks at the data and find a similarity between what this customer has watched before and what is his interest or what is his wish list, and comes up with their own recommended system. So this is the difference, I would say, when LLM powers a recommended system than when you have the typical recommended system before generative AI.
Like
Yeah,
a lot of times, like, just to sorry, like just to build on like that and what I said, right? Like, so some of these prompt engineering can answer something like, okay, hey, I watched these 3 movies, what should I watch next? And it'll have an answer. And of course, these like embeddings, as Lakshmanan said, like drive how the LLM is answering. But building further embeddings on top of these LLMs, right? Like I can capture things like what are some of the let's say I can add more information to the mix, like what kind of movies has this user rated on IMDb, for example, or on Netflix, for example. This additional information could be part of building these embeddings and driving like secondary models that can make even better recommendations. So I watched these 3 movies last, but I've been looking on Netflix in the last 5 minutes for something more lighthearted, not the horror movies that I watched, right? That can drive a different recommendation than if I just said, like, these are the 3 horror movies I watched. What should I watch next? So that's like an additional layer on top of it. Sorry, go ahead, Ruchi.
No, I was just saying, Chinmay and Lakshmanan, you guys probably just described RAG that is probably used in all the places these days. So even like I told, we use it in chatbots where we use RAG to just like fine-tune the model with the external knowledge of interaction, like past interaction between the customer and the service provider. And generally, you just store these interactions in form of embeddings, and then what happens is you just look for nearest neighbors, cosine or whatever technology you're using to find the nearest neighbors, and that's how you find like what are the similar results to something that you're looking for in your prompt. Yep.
Yeah, that brings up a whole different discussion on RAG architecture. Thanks, Ruchi, for bringing that. Yeah.
Yeah, so retrieval augmented generation is what you're referring to, right? So you mean to say that Netflix, I don't know if you can disclose the company information, but if you can, so does Netflix use retrieval augmented generation for building the recommender systems?
I would not be able to tell you for sure because obviously I'm not a part of that team. But we do use RAG in many multiple projects or products within Netflix itself when interacting with a LLM.
Yeah, even Ruchi is part of the team. She's not supposed to share this in a public forum.
Okay. So we talked about hallucinations and a little bit about their risks, but going back to Lakshmanan's point about mitigation of this risk, how can hallucination risk be mitigated?
That's a lot of, I mean, there are a lot of ways. Maybe I can quickly touch up some techniques, and then maybe we can open up to Ruchi and Chinmay for a deep dive conversation. So yeah, I mean, see, hallucination can be mitigated with prompt engineering, which we have discussed, which is like, for example, zero shot, single shot learning, and all those types of learning we have, and it can be reduced with the help of, again, this embeddings or RAG architectures, which is like you are grounding them with your own data, specific data, or you can use the, keep the model, froze it, and add a few layers. That's like changing the weights on top of it. That's called as fine tuning. So there are multiple ways I would think. I mean, I would love to talk about. I mean, like to say. I mean, pick that these 3 would be. I mean, the topmost ways. I mean, that customers based on my experience, are using it to avoid the hallucination. Yeah.
I also wanted to add, like, we all talk about temperatures when we are talking about generative AI. So maybe, so if you've heard, like, when you lower the temperature of an LLM, it means that you're reducing the creativity and randomness of the model. So in that case, it could also lead to controlled hallucinations. So the LLM will not generate more random data or not be very creative and create its own data in that case. So in those cases, the responses from the LLM will be more specific and more contextual to what the user is asking for in the prompt. So, and then leading to lower hallucinations.
Yeah, exactly. See, that depends on the use case. I mean, some use case you want LLMs to be creative. For example, ad generation, right? I have used this. I mean, in one of
But
my
you need
customer.
validation.
Sorry.
Yes. No, you need validation as
Yeah.
well. Like, I agree with you.
Yeah,
Or
yeah.
creating
So
stories or
Yeah.
poetries where you need more
Yeah.
creativity within the LLM
yeah,
itself.
exactly. Like, yeah.
Yeah.
So that is one of the prompt techniques. Yeah, exactly. Yeah, I agree with you. Yeah.
Yeah,
So
no,
temporary,
definitely. As you're, so once you have these like models deployed at scale, and a lot of these times your companies are also collecting data to train and update these models on. So like one of the most important things when you have something deployed at scale in production, where people around, like, your customers globally are seeing the results of it, are being served predictions of these models, it's important to have like validations, constant validations on retrainings, testing with previously unseen data, to make sure that if I generate an ad about, like, toothpaste, right? Someone showing someone brushing their teeth, for example. That might be a terrible example, but, like, it should know what teeth look like. It should not have pointy teeth on, like, like 100 teeth on like a human face or things like that, because that's a hallucination that's happening, right? So creativity is great, let's say when you're generating abstract art, but when you're serving like real life predictions, generating ads, serving ads, you need a constant system to like automatically validate things, to kind of like check on making sure that the system is not going haywire. You need to make sure, like, there are no biases. Well, it's hard to make sure there's no biases in your data, but like you need like better practices, like, processes to catch when there's biases in your training data leading to hallucinations, and better data curation, cleaning practices to make sure that something bad doesn't go into the input of training your model and cause
Exactly.
more problems. Yeah.
Yeah. Another thing that brings up, that sparks my mind when you're talking about this, Chinmay, like human feedback, right? Reinforcement human feedback, right? That's pretty important. So when we talk about AI taking away jobs, for example, right? So this is a great example where you need a human team or evaluation team to evaluate your model's response, right? To make sure you pass the feedback back to your prompt engineering, or pass the feedback to your fine-tuned model, right? So yeah, this is also another technique. Like, you have actual human in place, like your team can evaluate the LLM outputs and fine tune it, and prompt, using the prompt engine, say that this is not what we expect, right? So tune the model as we go along. So that is another technique. Yeah.
Yeah, a mixture of automated and, yes, human validation and checking. Yes, agreed.
so going back to Lakshmanan's point, you said zero-shot learning can also help prevent hallucination. I mean, how is that possible? I mean, few shot, it is understandable. You give examples and try to make it more focused, but how can zero-shot learning help reduce hallucinations?
Yeah, that's a great question. I mean, again, it depends on the use case. I mean, sometimes, again, depends on the customer use case. Some customer doesn't want prompt engineering. You grounded the information with enterprise data or any other data with help of other techniques which we had discussed. So in that case, I mean, zero-shot learning. I mean, zero-shot prompting may help. Again, it depends on how, because you're not taking your model as it is and use it for productionized systems or any production recommendations or any creating the content or generating content from this. So again, I mean, if you are okay, if you are fine tuned, you are changing the weights or you are using other techniques, some cases, yes, I mean, this can help, but this is not the only technique, right? I mean, again, this is not going to help alone, but it has to be combined with other techniques that we've been discussing.
So, like changing hyperparameters that Ruchi mentioned, like the temperature, is what we are going to do with zero-shot prompting, right? Is that what you mean?
No, see, temperature, changing temperature, and all those things would comes under prompt engineering, like because you are instructing LLMs to do what is next, right? So what I'm trying to say is no more about the embeddings, right? The vector search or storing data, like our connectors, for example. In Google Cloud Word, if I give an example, we have something called connectors, which we connect, you can use it to connect your own specific data, right, along with LLMs. So which would make sure that your LLMs won't hallucinate or cannot generate. I mean, we can reduce it, I'm sure. I mean, it's not like 100% can be reduced like any techniques, but we need to evaluate continuous. That's what this technique is all continuously monitoring and continuous evolve. That brings another topic, LLM ops, but it's not like 100% guaranteed, but of course, yeah, you need to continuously monitor your LLM systems output and tune it, fine tune it, yeah, with other techniques.
So if you really want like your system to work with zero shot learning for your clients, right? Say one of the examples I was reading about a few days ago was these LLMs are, people are trying to use these LLMs to set up kind of like a legal advisor, right? And most of these LLMs have been trained on like a treasure trove of data. People say like they've been trained on the internet, but the percentage, the amount of legal context, legal data that was included in the whole training set was minuscule, right? So firstly, I think as Lakshmanan said, like you need to fine tune these models to train on that specific context so that they can answer questions more accurately about or legal questions more accurately than ChatGPT as it is like plain vanilla would answer. The next thing is you have to keep them updated with like new laws as they come up, right? And you could on the back end kind of like few shot learn train the system, but if your legal GPT is trying to answer questions about all kinds of like domains of law under the US governance system, then you cannot kind of like do that on the back end. At the same time, you don't want them to get creative, right? So you have to sometimes you might need to have multiple smaller LLMs that cater to different domains, like piracy law, privacy law, what is that, copyright law, patent law, things like that. Or you might just need to like train it on a more regular basis and validate it on a varied context of like on a varied amount of like prompts where like questions are being asked and like you see what kind of answers are returned. You need human validation to make sure that your service is not misleading your clients, things like that. So you can still achieve a fairly good result with zero shot learning or like zero shot service, learning based service, if you take some of these steps to make sure you can serve fairly accurate predictions.
Yeah, thanks. So that makes sense. So can you think of any other tools or techniques available to deal with this hallucination problem?
Tools, I mean, I can talk about from cloud providers perspective since I've been working in the cloud. I mean, not third-party tools that I'm aware of. I can talk about like, there are, I mean, the tools are some, I would say the databases, vector databases, for example, Pinecone, which is pretty popular embedding database, which is the third open sourced one. And we have a lot of vector databases called in Google, we call it like vector search, which is like our matching, which was called as matching engine before, but yeah. So similarly, I would I would think that Microsoft would have the similar databases like for storing the vectors. So there are different. I mean that's the whole reason why this vector database concept was, I would say research. It was in research for a long time, but I would say the tools. I would say the vector search, maybe prompt engineering is a art and science, right? So it's not a tool, but prompt engineering is the it's not a easiest thing, but it's like you talking to a system in a plain English, right? That's an, I won't say it is a tool. I would say it's a technique or an art or science. That is one of the other ways you can, improve the system, right, without hallucinations. Yeah, go over to other panelists.
I would say, like, what Ruchi mentioned has become a popular term over the last 2-3 weeks, and what you just described, like RAG, you could kind of call it a tool. It's using, like, vector databases to hold more context that can give you better answers compared to a plain vanilla LLM, or something that an LLM that does not lack or does not have information to give accurate answers about a particular topic. So RAG is a pretty relevant tool, I would say, that can help in reduce hallucinations and give more accurate answers.
So Ruchi, you want to add anything?
One thing that comes to my mind, it might not be a tool, but just in general, to use smaller models and more context-based models. So, for example, like Chinmay said, legal advice, when you're seeking legal advice, maybe, having models that are catered towards specific use cases. So those models are more trained on those contextual data than broader data like ChatGPT. In that case, the model has the expertise in answering those sort of queries, and hence reducing hallucinations.
So that basically goes back to the RAG concept, right? So
Correct.
prompt engineering and RAG seem to be the top in the list. So
I think also what
fine tuning, right?
Yeah.
So what Ruchi mentioned, the concept is called fine tuning, which is like you take the bigger LLMs out there and fine tune it for your specific use case and make sure that you answer the questions to that, right? So that is called fine tuning. So again, again, it depends on the different use cases. Not many companies have the time and effort to fine tune a model. Fine tuning a model is taking huge amount of compute resources and all those stuff. Again, yeah, that's one of the techniques which I would like to highlight. Yeah.
Didn't OpenAI just change that with their conference a couple of weeks ago? You can fine tune your own model on their system, but yeah, no, coming back to your question, right? Like, I think Ruchi mentioned smaller models. Before the explosion of the GPTs and the LLMs, I think one of the things that researchers were working on, and I bet they're still working on it, is like, transparency and reasoning of how a model is actually working, the inner workings of a model, right? Like, why is a model giving an answer that it is? So reasoning, I would say, is another tool that can help us understand and mitigate the ill effects of hallucinations. Now, it's a lot harder with how complex LLMs are and the pace of the development, but I think for the research and the inner workings of like how LLMs are doing what they're doing, would having that as a tool would definitely help with mitigating hallucinations.
So in addition to the RAG, I think you're referring to parameter efficient fine tuning, PEFT, as well, right?
Yeah, PEFT is one of the techniques. Yes, PEFT is one of the techniques for fine tune LLM models. Yeah, there are hyperparameter. There are multiple fine tuning, right? Types, multiple ways you can fine tune a model. So one is like you don't need to spend much time and effort. Like you just change a parameter, that's called PEFT, and there is another one which is like you spend, which I talked about, like spend a lot of time and effort and compute resources to fine tune the model.
Okay. And what role does transparency play in addressing concerns related to misleading or harmful AI-generated content?
Well, so transparency, again, as it relates to reasoning, right? Like if you can understand what kind of data, what kind of content a model has been trained on, and what kind, how the model actually works, it is basically giving you transparency into how the model is reasoning and creating its predictions, right? So when you're able to reason about how a model is answering a particular question, and on the basis of what, it's going to give you a more analytical way of answering, like, how the model performed and whether it was a hallucination or not, how accurate is an answer given by a particular LLM. So I think it is a pretty important metric, if we call that, or a tool to measure how a model is performing or whether it's hallucinating.
Yeah, I would say, like, to build on what Chinmay said, I totally agree. Like, transparency plays a major role when you're dealing with LLMs, and user understanding how their data has been used to train the model and how the response has been generated by the LLM. But the other thing where transparency plays a major vital role within LLMs is in building trust and accountability with the model itself. So the user knows, like, where that response is coming from. The user trusts the model. The user trusts the model's response and uses that response in whichever way the user wants. Which also helps in bias mitigation, because you know that the data is how the data was used in training the model, and hence mitigate the biases that might have been generated by the LLM otherwise.
It also helps
Yeah.
with like improving the model itself, right? Like if you understand, if you have transparency into the inner workings and whether users trust the model or not, and for what reasons, like you're able to rectify the negatives, rectify the issues, and improve it.
Yeah, I agree, Chinmay. So yeah, this is something we call it like model interpretability or something, right? I mean, in different worlds, right? So yeah, it's like that's where the future store, all those comes into picture, right? You know how much each and every feature of your model contribute to the output, right? So for example, Vertex AI is Google Cloud tool, which just share that this analysis like interpretability, or we call it like explainability of the model, right? Where you see like what is the impact of the specific feature from the data and how that contributes, and you can generate a picture or diagram out of it and say how that impacts the output, right? So those kind of the tools are baked in now, in different cloud providers. So yeah, that is, as everybody mentioned, yeah, transparency is needed, like how model predicts the output. Yeah, this is something, yeah, plays a huge role. I mean, the tools such as like model interoperability or explainability model or explainability AI, or so those are the terms in different worlds. But yeah, we need to religiously follow those techniques or frameworks or tools. Yeah.
So then the question would be, are there any ways to build transparency? I mean, you mentioned Vertex AI has something like Lime or Sharp built in, is it, into the Vertex AI models?
No, Vertex AI is not a model. That's a tool, right? It's a tool given by Google Cloud for model development, deployment, monitoring, serving, interference. So we call it like a single uh, point of. I would say it's a one point solution, right? So uh, that so all those tools will have those you know internal features available. For example, for interpretability, yeah, we have talked about it, right? How we see how each and every feature impacts the output. So they are like a platform, or where you can use the whole model development phase, right? Irrespective of whether you're developing LLM or any other models, right? So yeah.
No, what I mean to say is, I know Vertex AI is a platform, but does that
Yeah.
platform build Lime and Sharp on top of these models? I mean, what is it using to provide the transparency?
No, that is something I don't have much insight, like the exact details, but yeah, maybe somebody else can share those insight. Like, yeah, I know those are the features available, but I don't know the inner workings, like what are the specific other, parameters or with that use it. Yeah.
Okay. So now that we talked about Google's Vertex AI, can you share more such insights into how companies like Google or OpenAI or Meta kind of address hallucination when developing or using large language models?
I don't know. I mean, I can make assumptions here, but maybe these are the techniques, right? Like the prompt engineering, again coming back to the same basics: prompt engineering, RAG architectures, fine tuning, and what else? Yeah, so these are the techniques that comes to my mind. But yeah, they might be using the same sort of techniques to avoid hallucination for their own models, like OpenAI models, or Meta's Llama models, Google's Palm, or I would say bad Palm models. So yeah, so I would assume, and I'm guessing it here, but I don't have much insight on how they are. I don't know whether it's out in public also, but yeah.
Yeah, so there's two types of now models in the LLM world now, right? Like there's the LLM model, there's open source models, which like the llamas and like most of its derivatives out there, and then there's the closed source models like Google's Bard, or I forget the model backing the Bard, and then OpenAI has its ChatGPT models, right? So with open source models, because they're open source, there's information about how they are being trained, on what they are being trained, how they are implemented. There's a lot more explainability, and people have insight into how those models are working. I'm not using the word transparency, but like how they're working more than the closed source models. And they're able to basically evaluate and improve the performance of those models in order to hallucinate less and less. On the OpenAI side, based on what is available publicly, I can say, like, OpenAI, if you're a customer of OpenAI directly, they, unless you have some special agreement with them, they will collect the data that you're feeding to the models to continuously update and retrain their systems. And again, they have been in this business of selling LLMs as a service longer than anybody else has. So they have systems that constantly are evaluating a bunch of performance metrics, including hallucinations of their new models as they're updated. And these systems include automated systems that are testing it against a lot of commonly asked questions and see how the responses differ before and after a new training cycle. And they also have human evaluation of responses to make sure they are improving the models with further training and tweaking and not regressing backwards. I'm assuming, like with other closed source models like Gemini, I believe, is the one backing Google Bard. They would be doing the same thing, being responsible in that manner to make sure we're improving the performance and the utility of these models as we continue to iterate on them.
Yeah, so yeah, in addition to that, I mean, that's what we call it, like responsible AI framework or ethical AI framework. Every you might see that framework in different names, but it all talks about all those best practices, right? Like ensuring the user privacy and transparency of your model, and avoiding the hallucinations, and how do you ensure that the user security is maintained. So that's a well-defined framework available. So any product or anything that we develop, I mean, any customer develops, or anybody using LLMs or using the LLMs API, make sure they have their in-house AI framework, like which talks about all those concerns, right? And what are the best practices they need to follow.
So, Chinmay, you mentioned metrics, something about metrics. So, what are the typical metrics to measure the quality of hallucinations or the quality of the output of these LLMs? Do we use the regular blue score and things like that, like we do with NLP, or there are different metrics?
But you can use some of those existing metrics as well. I've seen them being used in the industry because, see, LLMs and Gen AI is so new. People are still working on trying to figure out how to evaluate the response or the predictions generated by these systems well. Of course, human evaluation is a lot more accurate, at the same time more expensive or difficult to achieve. Like, you ask a question to an LLM and see how accurately it answers it. Does it make sense? Or is it completely throwing you off? Is it giving a completely fake answer, right? That's a basis. That's a baseline thing. Other metrics you could say is how often can it recall an accurate response based on what is supposed to be common knowledge, or say responses based on common calculations, things like that. So you're also kind of trying to calculate, trying to how do I say, transform whether it's giving the right answer or the wrong answer into your usual like accuracy, precision, recall metrics to make them more interpretable, to make them more comparable, things like that. And at the same time, like, you're basically also seeing business metrics being pulled into it. Say, like, if you build a product based on your LLM, right, and is being used, like, how is that helping or not helping your business based on the usage of the LLM specifically, right? So if an LLM is deployed and you retrain it on new data, or you tweak it in a particular way, or you fine tune it, what impact did it have in your business, right? That is another thing that's being used to kind of find out, like, hey, where did we go wrong? Like, is it because of hallucination or something else? So, like, to detect things like that, because when you're running a business at scale, and if your clients are seeing hallucination, say 0.1% of your clients are seeing like the effects of hallucination, maybe not even hallucination directly, it's very hard for you to catch it manually, right? But some of these business metrics that you can backtrack into how your LLM was responsible for serving a prediction that led to some user interaction, you're able to backtrack from that and see, like, okay, what happened here? Was it a hallucination? So, like, I've seen new metrics being created to catch things that you might not be able to catch using your model, like what are generally accepted model metrics that have always worked for like our conventional models. So people have had to get creative and create new metrics that fit them to catch hallucinations.
Yeah, I agree. In addition to that, I would talk about two other aspects, like which I think Chinmay touched upon, like accuracy metrics or accuracy score, where you can evaluate your LLM model with a baseline accuracy with your own data and make sure it does matches. So that is one of the way to detect the hallucinations with some accuracy metrics. So it's a combination of all the metrics, right? I mean, it's not like one metric which tracks the performance. So, and another one is safety or harmful score metrics. For example, LLM may hallucinate by maybe throwing some harmful content or some content which is not to be digested or consumable. Like, it may send some derogatory remarks or harmful content or something like that, right? So those are other areas as well, those two metrics. So it's like most of the combination of your traditional metrics like Rogue or the basics one, and specific to LLMs like accuracy as well as safety filters. So every cloud product comes with the safety filters, which can be configured like, hey, 0 to 7, for example. Like, so allow only this. If this is something LLMs are trying to hallucinate, you block it. Say, I can't reply, or maybe some user-defined messages like, saying that, hey, we cannot answer these questions, we cannot answer that question because so-and-so factor, right? So those are the metrics you can track it as well, and you can prevent that.
I can also talk about my specific use case where I talked about we've developed a system where customer interaction between the support person and customer takes place via the LLMs. So in this specific use case, as Chinmay said, learning from human feedback or reinforcement learning from human feedback. Generally, what happens in this is when a customer is interacting with the LLM via a portal or a chatbot or anything, the chatbot or the LLM responds basically as the chatbot is backed up by the LLM. Feedback is gathered essentially whether the response helped the user or not. So we have like quick, thumbs up or thumbs down whether this response was in alignment with what the user was expecting, or whether this solution helped the user in help centers and specific use cases. and through those metrics, they are gathered on the back end. And we know, like, some queries, let's say the user is asking for a specific solution or a specific question, and it's a pattern that gets bounced every time. The LLM is not able to respond with this specific question. In those cases, we gather the analytics in the backend, and we know like which queries are being consistently not being served to the user, or the rating is fairly low on those specific queries. So in that case, that the LLM might be hallucinating with some answers, and there are inconsistencies there, and you use those use cases to understand like where the LLM can be improved and what data set might be lacking.
So this is like I said, like businesses trying to
Right.
get creative, create their metrics so that they can back out to like, hey, is my LLM, is my system hallucinating?
That's correct. Yeah.
Yeah. No, I've seen a lot of that, so that makes sense. Thanks.
Okay, so yeah, thanks for those answers. So one other aspect that I wanted you guys to touch, if possible, is on synthetic data, right? So what role does synthetic data play in the generative AI era?
I think from my experience, I can talk about data privacy. So let's say in use cases where customer PII or private information about the customer is involved, in those cases, you cannot train the LLM directly on customer data. In those cases, like generating synthetic data that aligns with those real-time scenarios is very helpful, because these are again synthetic data. They are not real data, but they mimic the data in a very real world use case kind of a way. And that helps a lot in fine tuning or training the LLM to further answer those kind of use cases where these sensitive informations are collected, but they are not trained upon to the LLM.
So it's more like differential privacy techniques, right?
Correct. Yes.
So we are basically introducing noise into the real data.
Into the real data, and also like creating anonymity within the data itself. So the data will not carry any PII within itself. So you basically massage the data in the way you take out all the customer PII and then introduce the data with like synthetic variables in those cases.
Okay.
Yeah, there is another use case also, like, yeah, when you want to mask it, but there are some cases when you don't have data itself, right, to train it. So that case, you can create your own data with the help of synthetic data to train the model. So that is another use case which I have experienced with the customer, like, yeah, privacy, transparency, that's a major use case. Like, you are going to mask their sensitive information, for example, driving license, date of birth, and all those examples, right? So, but in case there is no data available, you want to train something, you can create your own synthetic data. That is also another use case. I would like to share that as well.
Yeah, I think it's a mixture of both, right? So you mentioned privacy, Vishnu, and you mentioned differential privacy. So yes, differential privacy and K anonymity are like definitely techniques that are used to train models of all sorts while protecting users' data and respecting their consent to not be tracked or not have their data used. But when users say don't use my data, like again to Lakshmanan and Ruchi's point, like you're lacking in training your model in a way where it should respond correctly to a real world question when you deploy a model in production. And that's where like generating synthetic data based on what would have been is very valuable to train a model that is less likely to hallucinate and give a real response. If you don't do this, if you don't use synthetic data to train a model, it'll either fail to satisfy your business use case, or it will, give wrong answers. If it's nice enough, it'll say, I don't know. But like if it's not, like it'll probably give you a convincing fake answer and mislead someone. So synthetic data is, I think, like serves a two-pronged approach of like, upholding privacy and consent of users who are providing the data, at the same time giving utility to the user who's using your model.
Yeah, I also wanted to touch upon what Lakshmanan said about LLMs trained on synthetic data for scenarios where you do not have real world data, or it's not possible, or it's very expensive to collect those kind of data. So one such example that comes to my mind is like fraud detection within financial institutions. So for a particular financial institution, you may not have all kind of fraud scenarios to train the LLM upon. In those cases, synthetic data or like user generated data might be very helpful, because you basically cannot gather real world data in this case. All you have to do is curate your own synthetic data to mimic that real world scenario.
But to both of your points, right, Lakshmanan and Ruchi, so this is a case for a normal machine learning model, but we are talking about large language models. Do you really think that large language models need synthetic data, or are there any instances where LLMs have been trained on synthetic data?
Yeah, large language models it's like generic model, right? You train with whole lot of information, but let's say you want to specifically customize for your use case, for example, which we have talked about, like legal or advertisement, any industries, right? You want to customize it for finance, you want to customize it for specific data. In that case, you don't have that specific too much information around that data, right? On that domain, around that domain, for example, legal domain, let's say, right? Your large language model might not have trained into too much specifics. Maybe it was trained on at the higher level, maybe at the surface level. Let's say you want to have more specifics into parameters, which is like very, very important to make a decision, right? So those kind of things, if it is not available, yeah, we have seen that people have gone for generating it using our customers seen that. We have seen customers going for creating a synthetic data.
So
And one interesting, yeah, go ahead. Yeah, sorry.
Yeah. No, I was going to say there are some scenarios, right, where you cannot have, or you cannot get enough data set for what you're a particular let's say experiment, right? I remember attending a talk a few days ago about training a model to detect when your truck, our trucks that transport all the goods and services, not services, goods around the US, right? When they will fail based on the usage patterns, based on the usage patterns of parts and things like that. And you can't go and fish for sufficient data on these truck failures, or you can't make enough trucks crash by putting defective parts in it to collect that data manually. But there's enough understanding of hey, if the tire pressure is this much, or if it's if certain parts are fatigued to this level, you are more likely to have your model fail, or your truck fail, right? So scenarios like this, you generate synthetic data to basically train your model to predict, given a certain condition of your truck, is it likely to fail or not? You don't have enough positive use cases of failure, when you're doing when you're mapping your X feature vector to Y, you don't have enough instances of truck failures as compared to not failures, right? So in case of LLMs, it's a little similar. If you're trying to teach a model not to answer questions about how to commit, say, violent acts, or how to build destructive devices or things like that, right? You might not have enough data points to train your model on those bad things, but you could generate synthetic data to train your model to say I'm not going to answer that question when I see a question like this, right? That's where synthetic data is really valuable. Again, I've read about this. I don't know if it's actually trained at a ChatGPT or something's trained using this, but to answer questions like, hey, how do I build something that blows up something, right? I want ChatGPT to say I'm not going to answer that question, and I have to train ChatGPT to answer that question. So that's where synthetic data is used in scenarios like those.
Yeah, I can also give an example, like a real world example over here in case of customer support, the same example that I've been giving until now. So essentially, let's say, again, like I'm using a very simple use case, but let's say Netflix comes up with a new feature that may require a customer to log in again to their accounts. And it might be a little bit annoying to the user might not anticipate that they need to log in, and they go to their TV or their phone and they see that the login screen is presented. The user might be taken aback, what's going on, and there might be a big storm of similar queries that might be expected as we roll out this feature, where users might be asking, like, why am I asked to log in again to my system? So in those cases, the interaction platform, which is backed up by the LLM, can be trained, proactively on a synthetic data, which is the query that they might be expecting in future as they roll out this new feature, and which can be later handled by the LLM itself when the actual rollout happens and the users start asking questions.
Okay, so going a little bit deeper on this privacy and security related issues, can you expand on the some of the privacy and security concerns that arise when using generative AI or large language models, particularly relying on customer or company data?
Yeah, data leakage is a big problem. If the model is trained on sensitive data, and let's say, for example, interactions between people in an email thread, which contains like sensitive information about the user, it might not be like exactly their PII, or it might contain some PII, but without users' consent, the data has been used to train the model, and in those cases it might just lead to data leakage and revealing users information. So that's a big concern, I would say, and informing the user about how their data has been used, like we talked about when we talked about transparency, is utterly important in those cases. So that's the biggest concern, as you said, Vishnu: data leakage and data privacy.
So a lot of times in my experience, right? So when you're training these models, they are trained, again, as I said, on the internet of data. And when ChatGPT was born into this world, like, within a year, it became the eighth wonder of this world, where, like, you ask it a question and it answers them as if it's an intelligent entity in itself. But that's not what's happening. It's important to keep in mind that, like, you're basically trained a machine learning model that's trying to predict what to say next or what output to give next based on the context in its context window, content in its context window, right? And what that means is, if you train the model with someone's personal information, if you've given it data about someone's address, their name, their phone number, there's a very high chance, there's a chance of a substantial chance that it might regurgitate that information out and cause a privacy leak. A lot of times when you're supplying data to the services that you use, if they are using services that provide LLMs as a machine learning layer, that your data might be inadvertently passed by your service provider to an LLM trainer that goes into the model, and that model might be used by some other company for doing something else, and you might have a data leak, right? So it doesn't have to happen by intent or like by knowledge of someone. It can happen like, completely inadvertently without the knowledge of like whoever provided the data, right? You might ask a very personal question to prompt or something, and you might think it's like, oh, this is not going out anywhere. What if that prompt is not cleaning out the personal information before using it to fine tune and train its own system, right? So that's where, like, inadvertently, like, there's a very high chance everywhere that interactions with these LLMs itself might cause major privacy data leaks.
I would also say, like, deep fakes might be a really big issue. that can prevail in today's world, where generative AI is just like so easily accessible to the general public. So let's say your pictures or your videos, if they are trained upon used by the LLMs, it can be used to create deepfakes. We've all seen, like, probably in LinkedIn or somewhere, where there's a conversation between Steve Jobs and Elon Musk, and they're talking about this like space stuff, and their actual voice has been mimicked in a way that you cannot tell that it's not coming from the real person. So that remains a big issue in today's world of generative AI, where deepfakes can be created, even like concerns in the porn industry, where persons' images and photos can be used to create those kind of disturbing contents.
Yeah, and that's an excellent example, because that shows that, like, when Steve Jobs or whoever, like, their pictures were put on the internet, they probably weren't put back in the day by Steve Jobs. They were put by some photographer, some news article, something, and their likeness now is being used without their consent, without their permission, to like build something else, to generate new content. And that's where the problem lies. Like, there was no intent of putting this data for use in this way, and it's happening. And that's that is something that like didn't exist like this before. Someone had to have in most cases have like what do you call maleficent nature to do something like this. But AI can very innocently, or LLMs can very innocently, like, cause privacy leaks just by interacting with the users and their data.
So Vishnu, just in adding to that topic, I just like to quote one of the examples where you might have heard, like Universal Music had issued a lawsuit on Anthropic model on using one of their music as trained and without the copyright violation, right? So that's the point, right? Again, Vishnu was mentioning, right? You need to have a consent of the data that's being used to train your model, so to avoid these kind of privacy issues, like So every government, it's not a individual responsibility. It's not even organizational responsibility. It's now every nation has its own framework around how everybody's developing the LLM models. You might have seen that US had received the recent announcement on on the policies, right? How bigger companies who create the models should follow these procedures, right? So it's at the international level, country level collaborations is needed to address all those challenges, like privacy and security and transparency and all those data. I mean, with respect to LLMs.
Okay, so we talked about the security and privacy concerns at the training phase, but how about deployment phase? Do you see any issues, or how do we ensure if there are issues with security and privacy at the time of deployment? How can we ensure or mitigate the risks of security and privacy issues during the deployment phase? Can you think of anything?
So this again comes to, like, validation. When you're deploying, training and deploying new models that are generating predictions, right? You want to have automated and to some extent manual human validation of these new models that you're putting into production, right? Yes, you're looking for hallucinations, but you're also looking for, like, are they leaking any kind of additional privacy data? Like, are they leaking PII? Are they leaking more innocent things that can indirectly breach someone's privacy, right? And I think we talked about, or someone mentioned differential privacy before, right? So there's frameworks. Yeah, as you can't do all of this evaluation manually. A lot of times, like, you have a certain set of, like, questions that are asked to these new models, and you're basically trying to see, like, whether the response how the response changed before and after the training, and whether it was still able to maintain differential privacy of a particular population that we know was included in the data set. Like, were we able to breach that, right? So that is one of the techniques. I know, like, Microsoft has, like, differential privacy suite that I've heard is used in evaluating how models that are trained and retrained are able, on a particular data set, are able to preserve differential privacy. So there's tools like these that are used to automatically evaluate how the model has evolved after a new training cycle before they're put into production. So techniques like that. Then there's of course, you have other models themselves that are trained to detect and scrub out PII as much as possible to mitigate the issue of risk. So you try to put a phone number in a conversation on Airbnb, I believe it'll get scrubbed automatically. And it can be a big nuisance, when you know who you, when you met the person you're renting the house from, but you're trying to give him some information, it gets scrubbed. You're just trying to communicate. But things like that, post-processing on the output of these models is another tool that is used to try to uphold privacy more and mitigate leaks, security breaches, things like that.
Okay, so in addition to techniques like differential privacy, k-anonymity, and I think these days it's mostly differential privacy, which is the de facto, kind of becoming the de facto standard. So are there any other guardrails or best practices that developers can follow when building generative AI products to avoid privacy leaks?
Yeah, I would say access control is something that comes to my mind, not just for LLMs, but any product deployment or training or whatever. Proper access control is very essential. So understanding who should have the authority to look into the data or access to the data or a specific part of the LLM is very essential while development or deployment.
So yeah, so ideally the AD model development, deployment, monitoring. So it's the guardrail should be in place at each and every phases of the the model development, right? For example, starting with as Ruchi mentioned, data privacy, or data control techniques, like for example permission techniques, like who have access to which data, right? So starting from that and data cleaning, data pre-processing, and then you go into the next step of developing your model. And so it has to be incorporated at each and every level until you go to the model monitoring, and then once you deploy, what are the techniques, right? So it has to be make sure your own team who curates the data have access, limited access, right? Or something like. So it has to be the whole. I would say that it kind of a DevOps process where you have the security and guardrail has to be implemented at each level to have those, to address those challenges, right? It's not only at the initial stage, not only at once you put the model into production, it has to be at all the phases.
Yeah, I think everything that Ruchi and Lakshmanan said, right? You need to have a proper GRC, governance, risk, and compliance process about how you handle data. If you're working with PII, data clean room processes that basically take in data, sensitive data that contains PII and things like that, and provides you differentially private data sets or things like that. You need proper access control to ensure who has access to what kind of data, and tight controls on how it's being used. And again, security is not a checkbox; it's an evolving area, right? Where we are trying to figure out how to do security right, how to implement privacy right, while still maintaining the utility and the value of the data that we are working with, right? So it's an ever-evolving process about building and using new best practices to avoid PII and sensitive information from being used for training models. And then on the back end, when you're using predictions of the model to ensure that data is not leaking out. And when all of that is done, you have to keep in mind, you can do all of these things. You should do all of these things to mitigate security, privacy risks, but you need to have a plan of action when a security breach or a privacy leak happens, right? To limit its ill effects. You need to be able to stop privacy leak from spreading. How can you mitigate the risk of things getting worse? So that's a plan of action, again, that you need to have a proper procedure to handle a situation when a privacy leak happens. So you don't live in like as I said, like it's not a checkbox. It's something that you've try to mitigate as much as possible, learn from, and improve on.
And also one thing I would like to note is privacy right from the first phase of development, which is design. So privacy by design. So you keep privacy in mind while, even designing your products. So keeping in mind like what information will be asked from the user. Are you proactively asking extra information that is not needed by the system to be stored? And again, like within development, when we are thinking about scrubbing of PII when collecting data from customers, and even in testing phases, like how the testers are interacting with the system, are they oversharing about their PII, or are they including such details while testing that can be retained by the model? So thinking about privacy in all phases of development is very essential.
Okay, so you kind of touched upon the legal framework a little bit, but can you expand a little more on that? Like, how is the regulatory landscape changing in these areas?
I think like I do not have a lot of depth in this realm, but I think like I read about this a few days back, a few months even back. California law has been passed when considering how the AI or machine learning is used, and how the data is, how users' data are used. So I think it's called CCPA, California Consumer Privacy Act, where the user has the right to know what data has been retained, or what data has been collected to train the models. And also like the user has the rights to delete or opt out of sharing their data that can be used by the training, and things like right to correct. So let's say if there are information that are used that relates to the user that are incorrect, the user has the right to change that data, correct that data, and also like not share. We can read more about it on the portal, but yeah, I think those are my 2 cents. Yeah.
Yeah, no, yeah, absolutely. So a few years ago, like I think even before LLMs are unleashed on uh, the world has become more conscious. I think Europe has always been like ahead of the United States over there. So like they came up with GDPR, which where regulators basically started talking about like how companies are collecting, storing, and using the data of European citizens, and tried to set limits on how companies can use this for profit, right? We needed to set up a balancing act between like utility of the data and respecting the privacy and consent of the users who own that data, who that data belong to. Of course, US followed with CCPA a little bit later, and more recently they improved on it, expanded on it with consumer CCCPRA, so Consumer Protection Right Act, which again expanded the consent framework, giving more power to the users to say, hey, you can how you can use my information, what you can collect, where you can store it, and things like that. And these are like strong interpretations. That's the reason anytime you open a website, you get a nice pop-up saying like, do you want to accept all cookies, or do you want to modify it, or what do you want to do with it? And I think that's the right direction to move in. But yeah, the reason for that is because now that with all the new tools and technologies that have come into the picture with LLMs, and even just like other advanced machine learning models, the capability to collect and process all of this data to draw insights, I think it's become more and more important to figure out like what we are using to train how, and what could be the side effects of that. This again goes into transparency and things like that, but where we don't see issues where models can actually be used to do harm, right? Like, discrimination, racial injustice, like these are major concerns with some of these same tools that can deliver so much more benefit to the society. So the regulatory landscape is again trying to represent the people here and work with companies that are building these models, right? They're not the enemies of the business. So they are partnering with businesses to figure out how can we maintain or even improve in some cases the utility of what businesses are trying to do, drive value for the companies, for the people, and for the economy, while also making interactions with technology safer, more private, secure for users of this world, citizens of this world using these technologies.
Yeah. Yeah. So thank you, Chinmay. That was a detailed one. So yeah, I would love to like share my perspective around this framework, which like there are different countries have their own frameworks. China has its own framework. UK has its own framework. US has its own framework, like Chinmay mentioned, right? So data privacy and collections, and they have given set of instructions to the uh, organization that are having the large LLMs, right? How they are operating, right? How they are collecting the data. So there are there are the guidelines in place, like government is asking those information, like some specific information, right? How is the model trained, and you have to report it. Let's say you start a company, you are creating a model, like you have to report your findings, like what is the techniques and how they're using, what is the data, and all those sort of things has to be like you have to report it, and all the government has the power to whether you are using the data in a right way. But one thing I would like to highlight is that there needs to be a fine balance between this guardrails and the innovation, because if you put too much guardrails and all the stuff, and uh, companies tend to stay away from innovating also. So again, I mean, this is like a clear balance between like uh, adding as much as guardrails versus like how you are allowing the companies or organizations to innovate, right, on building those LLMs and all those stuff. So it's a joint effort, as I already mentioned.
Yeah, so recently there was also this presidential executive order. So with all these laws in place, hopefully things will turn for better. But of course, I have my own apprehensions and reservations about it. My experience with CCP hasn't been all that great. So the implementation, I believe, is slack. But hopefully with this executive order, will bring some more regulation and reasonableness in the area. So let's close by, in case you have any closing thoughts, please, you would like to share, please go ahead.
Yeah, so closing thoughts, like, so a lot of things happening around with generative AI. I would say, like, as you mentioned, like right framework, right guidance, right best practices would again take us to the next step of the innovation. As maybe NVIDIA CEO mentioned, like this is the iPhone moment, right? I mean, so I would say, like, we are still in the early stages, but yeah, if there's all guardrail safety concerns around privacy, the hallucinations are all we have all those guardrails in place, I think, and we are going to transform the way we operate with the with AI making the decision making, and AI is going to help you in all the things that we have not even thought about it. So I'm pretty optimistic, and I think that we are going in the right direction.
Okay, so let me close by a nice analogy. So for this panel discussion, I think I acted as a prompt engineer, right? I prompted you with questions, and hopefully I also made sure that you did not hallucinate, and you did not, there weren't any leaks, privacy leaks about your company information. right? And we all complied with the regulations. So I think so. All this discussion was quite pertinent to our own panel discussion. I don't see any questions on the YouTube live or on Zoom chat. So I think we can close the discussion here. Thank you all for joining. Thank you, Chinmay, Lakshmanan, and Ruchi for sharing your insights. So hopefully we'll see you soon in another event.
Thank you. Thank you, everyone, and happy holidays to everyone.
Yeah.
Yeah, happy Thanksgiving. Happy Thanksgiving. Thanks, Vishnu, for the opportunity, and thanks my co-panelists Ruchi and Chinmay for the fruitful discussion.
Yeah, I had a great time. Thanks, everyone.
Yeah.
Thank you all.
Thank you very much.
Thank you.
All right. Bye.